Complete your next grounding system analysis with the XGSLab suite of tools. You can do this more efficiently and with greater accuracy. In GSA-FD, we will step through a project. Here we'll enter in our project information, so we can enter in the geographic location, as well as pertinent information about the project that we want to document in the model. Next, we'll set our reference standards. Here we can use IEEE Standard 80, as well as several other international standards for developing our compliance criteria. Also, GSA-FD provides you a capability to change your frequency, allowing for power system analysis as well as lightning transients. Next, we want to evaluate our soil model. So we can take this multi-layer icon and this table to manually enter in soil resistivity or soil model, or we can generate a soil model based off of native soil resistivity measurements using either the Wenner or the Schlumberger methods following the spacings provided below. Using this method, you can generate a soil model and capture this graphic for reporting. Next, we want to import our system, and XGSLab provides a powerful tool in order to import from your existing DXFs and give each layer specific electrical characteristics, resulting in a full three-dimensional power system that we have modeled here. Next, we actually will inject our fault current. So going to our conductor here, I can select my conductor and look at my energization in the dropdown. Here we can see I've energized my model with 20,000 amps. After analyzing the system, we can see a short table of our ground potential rise as well as the system impedance. Here we can see 0.1 ohms with a resulting ground potential rise of about 2.5 kV. When we look at the ground potential rise or calculate the surface potentials of our power system, we can specify a specific area where we want to see these results. We can visualize the ground potential rise in many different methods. Here you can see the or the maximum ground potential rise is generated right where our fault occurs, and the gradients drop off as we move farther away from that fault injection point. Of course, we want to be able to evaluate our touch and step voltages, and we are allowing users to do that with multiple color variations in order to express or show their results more clearly to their clients. When you're complete, you can just use this automated reporting tool in order to PDF your report and capture all of your findings that you have when moving through your project. In a typical analysis, you will need to define the phase conductor's current and voltage. And for a tutorial, we are first going to examine the steady state analysis. Here, under the source dropdown, we can see that these phase conductors already have assigned their voltage and current, so we don't need to do that for the tutorial. But in your real-world projects, you'll need to assign these according to your transmission line's configuration, voltage levels, and expected current. Now that we have our transmission line in our model and our pipeline with infinitely long lengths at the endpoints, we can now compute and debug this model. And here we can see the voltage that's induced along the path of that pipeline. We can also see this in the View 2D mode as well. Protecting critical infrastructure from lightning events is a growing concern in many regions of the world. Evaluating the performance of lightning protection systems for your critical infrastructure is now easier with Shield. Shield provides you a full 3D application for modeling lightning protection systems and structures that you protect. The Shield module allows you to enter either IEEE or IEC as a reference standard. From there, you can obviously import or draft your geometric information, the three-dimensional system that you want to evaluate. Here we have the blue conductors representing our lightning protection system, and these green conductors representing the structures to be protected. Then we can determine if we're going to evaluate our system using the rolling sphere method or the Erickson method. Hitting this calculate icon, you can enter in information like the BIL in order to calculate your striking distance. This is used in order to evaluate your system's performance. We can see a top-down view where we can see some of our system is not protected, and a three-dimensional view illustrates this from a different perspective. Again, red conductors representing non-protected objects. And we have our XGL view as well to display these results in a little more flexibility. A new XGS feature is the XGL CAD view. Here you can visualize your system in 3 dimensions. You can also incorporate 3-dimensional structures, such as a sphere. Here we're adding a red sphere that will be approximately have a radius of 50 meters. And when we apply this, you can see a large sphere enters into our model. The Nets module has allowed you to analyze multi-phase mesh networks for steady state, unbalanced power flow, and detailed fault information for current into the earth and alternative paths. The hybrid cell feature allows you to analyze the effects of AC interference on cables, pipelines, and other objects in shared corridors. Here, in our hybrid cell called shared corridor, we have a transmission line, and adjacent to it is a buried pipeline. When we go down, we can see that the conductor information for the transmission line is entered in the table below, as well as the conductor information or the pipeline's information. Looking at the results, we can evaluate the current that's going through our transmission line phase conductors. Here we see approximately 500 amps of steady state current is flowing on the phase in port 1. When we go to port 5, which represents our pipeline, we can switch to the potential view and see that approximately 3 volts is induced on that pipeline. Many features have been added to the soil modeling capabilities of XGSLab. Here, we'll show the multi-zone soil modeling capability to place landmarks. Traditionally, when you added a new soil resistivity zone, we would enter the coordinate system into the table. Now, using this place landmark icon, we'll be able to create a new zone and place that coordinate or that new zone into our drawing. XGL View provides several new ways to visualize your analysis, from ground potential rise plots of large systems or magnetic fields along transmission lines. You're able to better visualize the results of your calculations.